All right, so this is going to be a video about finding the area between the graph of two functions. And before we start the example problem for this video, I am going to be just kind of showing you the conceptual understanding of what we're actually doing when we're finding this area. We have this example graph right here where we have g and f functions right here, and it says the region between two curves, and it's kind of colored in red right here. To find this area, essentially what you're doing is using this equation right here. You're technically, what this equation is doing is you're integrating from a to b. So you're finding the area from a to b under this f function, and then you're subtracting off the area from a to b of this g function. So essentially what you're doing is you're finding this whole area right here. I'm going to try to color it in right here for f. And then you're subtracting off this bottom part right here that's below the g. So essentially you're just getting this part right here, which is what you're actually looking for. So that's conceptually how to understand how this equation works. Now we're going to be applying this concept to an example problem right now. So here we go. All right, so for this example problem, I have an f of x and g of x function, and I'm going to try to figure out the area between these two, the graphs of these two functions. Now I'm going to graph them out, but to graph them out, one thing that makes it a little bit easier if you find the points of intersection first. So that's what I'm going to do really quick is I'm going to find where these two intersect. And to do that, I'm going to set both f and g equal to each other. Okay, so I set them equal to each other, and then basically I'm just going to be solving for x real quick. So here we go. So I cube both sides. Okay, from here I'm going to subtract off the x minus 1. Okay, from here I'm going to factor. Okay, here I'm going to simplify. Okay, from here I'm going to factor this second part. I'm going to factor this part right here. And you should have everything factored. From here, we should be able to solve. We're going to be setting this equal to 0 and solving. So you're going to have x equals 1 as a possible solution, setting that equal to 0, which is going to be 0 for another solution. And then we're going to set this factor equal to 0 as well to get 2 as the solution. So we have 3 solutions here, 1, 0, and 2. I'm basically going to be using that to graph both of the functions and try to figure out what area we're trying to calculate. So I'm going to graph f of x in green here. If I plug in 1, I end up with 0. So I'm going to plot a 0 point right there. If I plug in 0, I get -1. So I'm going to graph that really quick. And then if I plug in 2, I end up with 1. So I'm going to graph that real quick. Now it's x minus 1 to the 1/3 power. So it's a cube root type of graph. So to do that, you kind of have to remember what a cube root looks like. It's going to look something like this. I'm going to kind of sketch this here. All right, so it looks something like that. And then in blue, I'm going to graph x minus 1, which is kind of easy because it's just linear, and it's going to look something like this. All right, so we have both functions graphed here, and you can kind of see the area that we're looking for in this case. It's this part right here and this part right here. Now we're going to use the area formula that we were talking about earlier. And one thing that's important to understand is the f of x has to be the function that's on top. If you notice, the f of x over here is on top, and the g of x has to be the function on the bottom. Well, what's interesting about this problem is they flip-flop what's on the top and what's on the bottom. As you can see, the blue, which is the g of x function right here, is on top for the first part from 0 to 1, and then it's on the bottom from 1 to 2, and f of x is on top from 1 to 2, where it's on the bottom from 0 to 1. So we're going to use this to basically figure out the area of this part right here, and then we're going to figure out the area of this part over here and then add them together. But we have to use 2 separate equations because they flip-flop what's on top and what's on the bottom. So the formula is going to look something like this that we're going to use to find this. We're going to be integrating from 0 to 1. And now it's important again to understand that the blue is on top here, and that blue we chose as the g of x. So the g of x is going to be on top first. So g of x minus the f of x, where the f of x is on the bottom. So this finds the area from 0 to 1, and then we're going to add this to the area from 1 to 2, only this time the green's on the top, so that's the f of x. So I'm going to put f of x in there minus the g of x, which is the area on the bottom, dx. Okay, so from here it's just a basic integral. I'm going to solve it real quick. So this ends up being the antiderivative for this part right here. This part is a little trickier. You might have to do u substitution, but if you notice, the inner function is linear. So what you can do is you can just do the antiderivative of this outer power of this 1/3 right here, and then just divide by whatever the slope of this inner function is, which in this case it's just 1, so it makes it a little bit easier. So using reverse power rule on this one, you would end up with x minus 1, and you have to add 1 to that power. So you would get 4/3 times 3/4, because you're dividing by that 4/3, and you're dividing all this by 1 here. So I'm just going to have to really write anything down for that. And we're integrating this from 0 to 1 plus, okay, now we're doing the same thing over here. And we already know the antiderivative because it's right here, so I'm just going to recopy it in there. All right, from here we're going to integrate by plugging in this 1 and this 0 into this whole thing right here, and then we're going to do the same thing with the 2 and the 1 by plugging it in right here. So here we go. So you plug in 1, you're going to end up with 1/2 minus 1 minus 3/4 times 1 minus 1 is 0, so we're just going to put a 0 in there. So that's if you plug in the 1. Now we're going to plug in the 0 here. You're going to end up with, you have to subtract 0 minus 0 minus 3/4 times -1 to the 4/3. -1 to the 4/3 is going to be +1 because you're going to do that -1 to the 4th. So it's going to be +1, cube root of +1. This will be the cube root part right here. It's going to be 1. So it's 1 times 3/4. So it'll be 3/4 here. Plus, okay, we're going to do the same thing over here. Plugging in the 2, you end up with 2 minus 1 is 1 to the 4/3 power. So it's 3/4 times 1 minus, you plug in 2 over here, you're going to end up with 2 squared is 4 times 1/2 is 2. So it'll be 2 minus 2 here, which is going to be 0. Minus, now when you plug the 1 in, you're going to end up with 0 minus 1/2 plus 1, because this part right here. So it'll be -1/2 plus 1. Okay. So I tried to group these as easy to follow as possible. So this part right here is going to be with the 1 right here. This part right here is when you plug in the 0. This part right here is when you plug in a 2. And then this part right here is when you plug in a 1. All right, the rest of it's just going to be all basic simplification. And then we're going to have -1/2 plus 3/4. This cancels, plus another 3/4. This becomes 1/2. That becomes -1, so that becomes -1/2 there. So you end up with this whole thing and this whole thing both being equal to 1/4. So it's just going to be 1/4 plus 1/4, which obviously equals 1/2, which is the answer. So this is a pretty involved example, but it showcases all the steps that you need to try to figure out the area between the graph of two functions. If you have any questions about anything in this video, let me know.